So welcome to the Node.js NAPI team meeting for the 12th of February 2021. We'll follow our standard approach of going through the issues that we have tagged for Milestone 11 in the ABI stable node repo. So let me just go there and I will share that. Okay, so the first one is rename primary branch to main. So I know I saw some more steps along that process. I know we'd taken a quick look. I don't know, Jim, if you had a chance to work or progress any of those.
Yeah, I think I have a PR on the examples.
Yeah, I do remember. That's what I was thinking. Examples. Right, that was this one, right?
Yeah, so if you rename the default branch, then you can land that PR.
Okay, so basically it's all set to go.
Yes.
I will go ahead and do that. When I looked at it, I think it was only like a day old, so I wanted to give a few more people time, but
Yeah.
I will go back and do that. Okay,
Okay.
good. And then we'll be done on that one. Is that?
Then I have a second PR. I'll do a second PR to change that NAPI. We'll start with the documentation here. So
Okay.
change the NAPI to Node API.
Okay.
That'll be a separate PR.
Okay, so that's good. So I'll go ahead and do this first step,
Yeah.
and then you'll submit a PR for next time. Okay,
Right.
so that
Yep.
sounds like we are working along. So let me see if I can get back to the right. That's good. Move to node microtime tag in order to continue the tutorial. So.
Yeah. That was a good PR. So I've approved that. That can land anytime.
Okay, so here, and it's been 12 days ago. Okay, so I'm just going to hit the squash and merge if you think it's ready to go.
Sure.
So there we go. Okay, good. So now if I go back to... Okay, so not this one. Oh, here we go. Okay, so this one we can basically close out, right?
Yes.
Right. Maybe I was looking at the wrong... I didn't go quite far enough back, but that was still useful. Right, that's where I should have gone back. Okay.
Okay.
Milestone 11, right. So renaming an API is something more appropriate and descriptive. So I think I've seen some PRs been going in.
Yeah.
I don't know if there's too much we need to discuss here, but.
Yeah, I'll do the examples and then I'll start working on the related build tools.
Okay, sounds good. So and I know I've seen Gabriel had at least 1 or 2 PRs on Node Core, so that's good. Okay, talk submission to OpenJS World.
Yeah, so that's ready to go. When I sat down to put it in, I need like a biography and a job title and all of that stuff from Kevin,
right,
as the co-presenter, and so I don't have that yet.
Yeah, I guess Monday is the deadline, right?
Monday's the deadline, so I could submit it without that and say that information was pending.
I think that would make sense in my mind. Like, I think you can go back and add in like the bios.
Right.
And so, yeah, if you haven't managed to get a hold of them, rather than trying to remember to make sure we remember Monday, it'd probably be good to just submit with a TBD or something in that section.
Right. And then I'll mention also, Gabriel, I see you've added on to this outline.
Yeah, I just added my name next to context sensitivity because there was nothing there. So.
Okay, perfect. And then, so I'll mention Gabriel and Nicola will also participate.
Yeah, I mean, I think it's just like in terms of the talk itself, it's kind of like you can only have only have the two people, but
Right.
like we said, we can have in a pre-recording, we can have cameo appearances, right?
Right. Yes.
So figure
Yeah,
out
I mean,
what.
like if the rule of two is to be strongly enforced, then I'm happy to give up my spot. Like, you know,
I think we
I know.
agreed that it was going to be Kevin and Jim who were going to be on the actual submission,
Yeah, okay, good.
and then the rest of us will be like, hey, if we show up in the video, well, that's just the way it happens, right?
Right.
Yeah.
Okay, so that sounds good.
Yeah.
I guess once you actually submit it, you can close this one out, and
Yes. Uh-huh.
and then we might have like a new one for actually like working on the content together.
Yeah. Okay.
Sounds good. Okay, stale issues. Let's get over to that. Okay, so I'll just open up a few of these. I know this one, I guess, is still back to right. I guess we talked a little bit about, and we thought it was interesting. It would be a good fit for like a supporting library.
Yeah.
We just don't have one, so it's kind of like not sure what quite to do, right?
Yep.
I mean, it seemed nice.
We have
So, but it's like
we have kind of two of these. Like one is run in Node thread, and the other one is by Super Locus, I believe.
yeah,
Is that sort of fire and forget thread safe function that takes care of everything behind the scenes, and that you can use like in an RAII way.
right.
And so those are both good to have, but I'm not sure that we want to support them in the Node.on API library.
Right.
So
So
that's
how we,
basically,
yeah, I guess what we'd want to do then is to encourage them to be in their own libraries, right?
yeah.
Just wondering how we do that so it actually happens.
Yeah, like I mean, off the top of my head, I can think of like starting like a new Node.on API extras repo, and then just have that sort of accumulate these things. But and use like, yeah, I guess these additions, they don't really use any. Well, no, they can't. I'm thinking like, do they need anything from Node.on API proper in order to work, right? But I guess they don't, because you know, they can always just use the C API, right? If they need anything that would be considered internal, you know,
Right.
maybe things like attached data, you know, that those utilities in like an API : details, you know, that they might want to reuse that. But yeah, I think even that is accessible if you include the public header. It's just discouraged from use. But I think in the case of a library adding, you know, extra stuff, I think it would be okay if they used like an API : details. So they could just become, so this library could become sort of a dependent of Node.on API.
Right. I guess would like an extras, or are these two things kind of like two different ways of doing something similar though? So would you even want them?
Both in there, yeah.
Yeah.
That's a good question. Yeah.
Like I'm just thinking like, because it's code that would be useful to share, but we don't really want to maintain it as part of an API, right?
Yeah,
And
exactly.
even if we created an extras repo, then I don't, you know, it may actually kind of be back to, well, and here's something that's kind of maintained, right?
True, yeah, and it is in our organization. Yeah, it's a tough call.
I wonder if like putting them into the Node add-on examples makes sense.
To be copied verbatim, maybe, yeah. They're pretty elaborate though, right? Like, and they have a lot of implementation, so they probably more than simple examples.
Right, but it's kind of like, you know, here's an example of some code you can clone and use if you want. It's like
Yeah,
it's a place to provide the code without saying, well, we're supporting it, right?
that's true. Yeah. Yeah, and it's basically sort of like, these are some perspectives on the thread safe function. Like one of them is to just, well, both of them actually are to just sort of create it and throw it away. Make the
Right.
the user interface for the thread safe function as simple as possible. So yeah, that's a good point. Yeah, we may want to do it that way.
Because that could be a way to, like, we can encourage people to say, well, submit an example here. It'll, provide a place for people to get the code and use it, but doesn't imply maintenance. Otherwise, creating, if they are interested in creating their own module, we'd certainly reference it and stuff like that, right?
Yeah, exactly.
Okay, so we discussed.
So
Sorry, go ahead, Nicola.
yeah, maybe so we don't want to to maintain the code of these node API extras. And what we can do is to list these add-on, no, or these extra code, and I don't know the right place, no, where to expose this information. In other open source project, for example, I saw specific repository called, for example, ecosystem, and there you can see all the maybe plugins or module that you can use, or maybe we can list these on node.js API repo, but in that case, yeah, these extras should be dependent on node.js API, in my opinion. So I don't know. Yeah, if the node.js example should be the right place.
Yeah, I think
in my opinion, so the example is a way to expose how to do something to who want to learn about native add-on in general. So
yeah, I can kind of see Nicola's point too. Like, if we add it as an example, then we expect people to copy it verbatim. So there will be like a ton of verbatim copies of it going around, possibly slightly modified and all that, to suit individual purposes. Whereas if we did, we could potentially make it into one of these extras libraries, with a big fat, blurb at the top of the README that says, that this is just like a repository of external contributions, and we do not actively maintain it, and so we would be expected to maybe at least once in a while look at it, but otherwise just concentrate on Node add-on API, right? We might even hand out some commit rights to the contributors that have landed their stuff in that repo. I guess what I'm saying is it could be like on the order of Node add-on examples, like that kind of a spirit, but yet requireable using npm, right? Because I think that's the key, is that folks would want to just add it to their package JSON and then include like an API-extras.h,
Right,
and
but
then
that's where I think it gets a little dangerous almost, right? Like, Because as soon as they do that, it's kind of like, hey, I want to use this magically without even knowing what's going on behind the scenes. But if there's nobody who's stepped up to kind of say, I'm going to help you, like, you know, basically we're saying we don't have anybody who wants to maintain it or even offer it, or right. And I'm just worried that as soon as you say, okay, well, you can just require it without even thinking, even if it says, you know, whatever, that's actually worse than forcing people to copy the code, in which case they might actually think about it and say, oh yeah, okay, I understand a little bit what's going on here. It makes my life easier.
Right. Yeah.
Kind of, in my opinion, it's better to, if something is unsupported, you should kind of be like, hey, I'm willing to understand what's going on there so I can fix something.
Right. Yeah.
Easier doesn't necessarily help. So it's a tough one. And it's kind of like creating a repo where we're not going to respond to questions or anything, right? That's kind of like, hey, it's here, you can require it, but don't, you know, nobody's going to look. I don't know about that either, right? That's kind of where I was like, but I do get the point about, you know, the main goal of examples is help people learn. This is not really in that vein.
Exactly.
And so it could be confusing. I was just thinking of it as an already active place that we do kind of, you know, keep an eye on.
Yeah, I mean, ideally, I think what would happen is that you know, that community members would sort of not only raise issues but also fix them, and they would be mostly, you know, working in this repo, you know, and then
right,
you know, and then but the problem is bootstrapping it, right? Like basically, I mean, we could ask this person and maybe Superlocus if they'd be willing to you know, post their code there and then maintain their code, right? Because you know, their code would be exposed to lots of users, and presumably, I mean, it works for them, right?
Right.
So on one end of the spectrum, it would just kind of sit there, and they'd be sort of sitting there as well, and all would be well, right? Now on the other end of the spectrum, you know, there would be lots of bugs, and you know, they would benefit from, I mean, the two authors would benefit from having these bugs found, right? And it would help their own code as well. And so that might be one way to bootstrap the ecosystem. So, you know, and you know, on the other hand, of course, it could just open the floodgates to like a myriad contributions, and we can't give everybody commit access who has a piece of code in there, right? Because then that would, well, or can we, or can't we? Like, why not? You know, you know, basically, I guess it would be like, you know, yes, sure, we can accept it, but then be prepared to support it yourself. You know, that would be the level of commitment that we ask from
the other option might be like we could create up a separate org, which would be like, you know, any API extras. Yeah. And in that org, you know, there could be individual repos, which when somebody had something like this, we could say, you know, you could put, we'll give you a repo in the we'll give you a repo and commit rights in this org.
That's good. Yeah. Yeah.
And so it's kind of like, hey, you still, okay, if you don't want to actually, you know, well, it kind of like says, okay, here's an ecosystem of things on top of an API, and but it's, we'd have to like make it clear that it's a separate org, you know, and
yeah. I mean, okay, but bootstrapping that involves some involvement from this org, from Node.js, right?
Yep.
In Node.js, we know what we have to do to start a new repo, but if we start a whole new org, I mean, do we have some procedure for that?
We did do it. We did PKGS as a separate org.
Okay. So, okay, good. If we have precedent, then we can just follow that if we choose to go this way.
So let's here, what I'm going to do is let's make sure that we've got some people who would actually do something. Creating a new org. Okay, we don't, okay. We don't want to pull too much into Node add-on API beyond being a wrapper. API. We already have a few different
spins on the thread safe function.
Yeah, wrappers for the how about that thread safe function. Don't think and don't think it. So that's kind of there.
To pull more of them in because you just said that we already have a few wrappers. We've already obviously pulled those in already.
Okay, I meant higher level.
More.
Maybe it's higher.
Oh, you're referring to PRs like this one when you say higher level wrappers.
Yeah.
Okay.
Yeah.
Because it sounds like you're talking about stuff that's already in the repo. Okay.
No, yeah, that's what I meant.
Okay.
And don't think it would make sense to pull them all in. We talked about creating a new repo that would be separate, a new organization.
Yeah.
See, it's a question like, would that organization need to be even tied to Node? I guess it's kind of like, yeah. But let's just say that we separate a new organization in cases like this offer a in that org.
Yeah. Would maintain that repo, right?
Right.
Okay.
I'd still like to keep on the table the idea that maintainers could create their own repos and that we would just have a directory of interesting repos.
Yeah.
Because that could be adequate.
Right.
Yeah, we could mention like the org in the readme.md for Node add-on API, and then people could browse the whole org.
Yeah.
Yeah.
I guess that, how about that? Is that kind of, because I agree, if people would just create their own repos and we had a list, that would be the easiest.
Mm-hmm.
So that will at least get us some feedback. And this one, it may actually be too late because it's a couple years old, but
yeah.
There's still a response. So let's
maybe can you maybe mention the author of this one and Super Locust as well, because they also have a PR that is similar in vein.
I was going to go paste the same comment into that other one. Does that make sense?
Yeah.
Oh, that, okay. So I'm going to have to do that, right? Okay. So let's go find that other one.
Yeah.
And there was which one was that?
Yeah. Let me go
this
check.
one, right?
Okay. Yeah. Yeah, that one. Yeah, and then you might as well mention them here.
Yeah. There we go. Is that good?
Yep.
Okay. Okay, so I think that's good. Any more discussion on that one before we move on? No. Okay. Right. NAPI reference can be copied. Can't be copied. So this one, I don't know if you have any, or Legendicast was going to take a look at this, so we'll wait to hear back from him. I do want to take the opportunity here. I was actually looking at another issue in RefNAPI, and there was a case where, you know, I would have liked to have been able to dynamically allocate an instance of a reference. But maybe I just didn't figure out how to do that, but it didn't look to me like we can. And I'm just trying to remember generally why we're preventing that. Is that, Gabriel, do you have any sort of remembrance of, I think in most cases where like the C++ is like, no, you can only stack allocate them, right?
Actually, one does keep like an object reference, you know, in like, you can add an object reference to like an add-on instance, and so that would be heap allocated, right? I mean, you would have to, because you know, with an add-on, like with an instance of the add-on class, meaning your entire add-on, everything would have to be heap allocated because it's stored on the environment. You know, I think
Well,
what
sorry,
he's
when
talking
I said
about,
heap, I meant stack allocated.
so I mean, basically this talks about copying a reference, right?
Right.
So you know, copying a reference means now you have two references which all refer to the same object, right?
So yeah, that was kind of a different issue than what I was asking about.
I think like I think there's no problem creating a reference that is stored like heap allocated, and the same thing can be said for stack allocated, right? Because you just say like NAPI reference : well, actually, yeah, because it's like object : persistent. I think, if I remember correctly, is how you create a reference, right? Let me check the code. But either way, in terms of addressing this issue, you know, you can copy a reference just by dereferencing it and creating a new one, right? I mean, I guess we could create like a copy operator that does that, you know, where it just gets the value of the reference and then it returns a new reference to that value. And so the original reference is in place, and now there is a new reference. But this basically,
you'd have to be careful in terms of like incrementing reference counts and stuff too, right?
No. It wouldn't increment the reference count, because it would create a brand new reference. So if you go back to like core node API, it would be like,
right, yeah, okay, yes, got it.
An API reference get value, and then an API create reference.
Yeah, no, yeah, okay, that would make some sense.
Yeah, so
but I think this one, Legendicast was going to research and add some comments there.
Yeah.
But the question I was back to, like with the current API, I wasn't having any luck creating a reference dynamically. But maybe I was just, if you're telling me it's possible, I was probably just doing it wrong. So.
Yeah, it should be. I don't see why the destination, whether that be stack or heap, should matter when creating a reference. But let me just double check. Class reference, there it is. So I mean, yeah, I mean it's just like, let me see, type name T. Yeah, so I mean, you can create a reference. You can, yeah, there's just like a static function, you know, an API : reference : new, which returns an API : reference. So, you know, if you do that, then, and I'm assuming, okay, this is templated for type name T, and I'm assuming T has to be like an API : object or an API : function or something like that. Otherwise it will fail, because we can't make references to primitive types. But the bottom line is it returns a value of type an API : reference angle brackets T, right? And so that can be assigned to.
Yeah, I tried putting that into like a reference, you know, bracket T, bracket star, not T obviously, but with the right type.
Yeah, yeah.
And it complained. So.
Really? Okay. So okay. Well, we can check that.
Okay. So that, I mean, it sounds like there's no fundamental reason why we think that shouldn't work. It could just be me messing, you know, not getting the C++ right to make it work. But it kind of looked like, you know, it's like, I know in some cases, definitely like a lot of the V8 structures are like, no, you stack allocate these. And, you know, in case of the reference, when it's, you know, it goes out of scope, then it automatically cleans things up and stuff. But I was looking at a case where, you know, I wanted to actually control the lifespan of it separately from the create and delete.
Okay, so we have something that's statically declared in a test/reference.cc. So we have static reference buffer uint at week, and then you say week equals week da da da. So,
okay, so you're saying in the test there's an example.
Yeah, test reference.cc. Okay, line 5, line 5 and line 6, 7, 8.
So is that just in the test here? Test reference. Yeah. Ooh, where am I looking now? Test reference. Object reference, is that?
No, just plain old reference. So yeah, a little further down.
A reference, there we go, okay.
Reference CC. So there's that static, right, at the top, and then you assign it inside create week array.
Right, yeah, okay.
So, you know.
Where is that assignment week? Ah, okay, so that's using, but that is, week is something.
That's NAPI : week, probably.
Okay.
Yeah, we need to see. Yeah,
interesting,
actually, yeah, I think.
It may, like that looks like there's a constructor, which I'm not sure that there was a constructor for reference itself, but that may be fine. Like maybe I just needed to use persistent instead of reference.
Yeah. Right. Yes. I think we have, because I think Nan did it the same way.
Okay. Okay, so I'll try it with persistent. I mean, that's effectively what I want anyway. So.
Yeah.
Okay, thanks.
Yeah, okay.
That's good.
Yeah, we have helpers week and persistent, which are just off the namespace.
Right. So maybe I just need to use persistent. Okay, that helps. Thank you very much. I will not derail us any further on that, but see, can I get back to right? So okay, so legitimate guest is going to look at that original one. Right, stale issue, sorry. Okay, so we've got a next step on that one, and then this one here.
Yeah.
Okay,
sorry,
so yeah, Nick, you were going to take a look at that one.
Yeah, I didn't. I don't have an update. In these 2 weeks, I didn't have the time to take a look.
Okay. But thanks, just good to, we still have somebody thinking about it. It's the key thing. Okay, so those were the stale issues. Tracking issues for things that were ported. So I guess nothing too new there, but we'll do our NPM, that on API look just to see. Okay, so it still seems to be tracking upwards, which is good.
Yep.
Certainly, like, let's take a look from 2020. I guess it doesn't even go back a year, does it? No, there's something. Okay. Anyway, it basically looks like we've gone from 400,000 to 3.6 million in the last year, which is quite good. So
you could use NPM stat website.
Okay.
So if you want to, I push on the chat.
Okay.
If you want, see.
Sure, let me bring that up. Oops. I think that's pretty close to what we want anyway, but this will node add-on API. So basically from 2020, oops, today is February 12th to February 21, February 12th. Okay, so it's funny how there's these ups and dips, but anyway. So definitely you can see just in the last year it's been a pretty good line. So okay, so that's good. Let's go back to the regularly scheduled agenda if I can find that. Where is the right issue here? No. Sorry, now I think I've lost. Right, this one. Okay. Review external examples. I know I haven't gotten to that. Debug testing for add-ons. No. I guess list of issues raised by module owners. If we go to, this is a little bit stale, I guess, but if we go to GitHub and take a quick look at node add-on API, are there any issues that people want to highlight or bring out? I think like some of these, this one, I think there was, Kevin had done some work to progress that. That's good. I know that most of them I've seen, you know, fair amount of activity and stuff. So basically, are there any that people think that, you know, we need to call out or talk about?
In the core repo, we have that, you know, that reference.
Yeah, let me pop over there.
That's about the only one. I think that one's ready to. But I did want to ask you one thing. Let me just get the PR. The PR is 37303.
Okay, so I think.
Oh, it's Node API nowadays.
Yeah, okay. I wasn't sure if that had been changed, but
I did. I changed it.
Okay, sounds good. So this one.
So then the third one. No. These are just, yeah.
This one. Okay.
Yeah, that one. Yeah.
Right. Okay.
So
yeah, I remember commenting on that one, right?
Yeah, and you were right. I did miss the case where during environment teardown it does not delete the reference, right? In that case, okay. it would still get deleted, but it would execute the finalizer twice. So then I changed it so that the finalizer only gets executed once and all the tests pass. However, if you look at the code, there are two ways of solving this, right? See here, I moved the finalize ran equals true. I moved that out of this else that you had down here, right?
Okay.
And so if we keep the finalize ran true inside that else, then we can prevent the finalizer from getting called twice during environment teardown by checking whether the finalize ran equals true, right? If you go above. If you scroll up a little bit where we call the finalizer, see, we could add to this if statement another condition that says if not ran.
Here, I'm going to switch over to the file view because it's a little bit finalize.
But it's going to have a few of those.
But here it is, right? Yeah. So okay. Yeah.
So you know, so the difference, if we were to move this back into that else there, then what would happen is the finalizer would run and it would mark finalize true and it would return, right? But because it didn't delete this reference, it would go back to the process of destructing the environment, right? And that process would continue by attempting to delete the next reference left on the linked list, which is this reference because it didn't get deleted. So it would call finalize again, right? And then as it stands now, the finalizer would get called again. And that's obviously wrong. You don't want to call the finalizer twice. So then you can do one of two things. You can move this finalize ran true out of that else. And so if you do that, as it's done here, then when you keep going, then it will enter delete, not because delete self is true, but because env teardown is true, right? And once it's inside delete, finalize ran equal true is one of the conditions for which it doesn't defer, but rather deletes right away. So in conclusion, if we leave this as it is, then it's not going to return to the destructor and then come back and then delete it, but it's going to delete it right away. Now, in the case where it's not environment teardown, then I suspect it's okay because all the tests passed, right? But in that case, the finalizer runs when the garbage collector is already in the process of running the finalizer, right? And so if we set finalize ran to true here, then it will not exit without deleting. It will call delete afterwards, right? And then that delete will actually delete because well, the finalizer has already run. So once again, the condition whereby finalize ran equal true will be met, right? But so it's kind of, you know, this change to move the finalize ran equals true out of there kind of upsets the code a little more than it should. But on the other hand, it does seem to work everywhere. Now, if we undo this change and we put the finalize ran equal true back into this else statement, then we also have to check for finalize ran equal false before calling the finalizer. Otherwise, during environment teardown, it's going to call the finalizer twice. So these are kind of choices.
I guess this is such a tricky area.
Yeah.
That I think I'd be tempted to check the finalize ran in the teardown.
Okay, I see what you mean. Yeah, okay.
Because I think we know that the regular case is pretty, you know,
pretty well handled.
I'd like to actually think through and make sure that, like, it seems to be working okay.
Yeah.
And if we add the, you know, the check-in is env teardown, that seems to be like minimal affecting of what's currently happening, right?
Right. There is one sort of philosophical, if you will, consideration, right? If the finalizer has in fact run, then we should set the finalizer ran to true. It should not be conditional, right? Because like the finalizer ran, why are we checking whether we set it to true or not? We should set it to true because the finalizer ran, and we want to mark that occasion unambiguously, right?
Right. Now,
whereas,
we're deleting.
Yeah, we're only saying finalize ran if delete self, right? Like if you ignore is env teardown, which is most of the time, right? Then we're only saying finalize ran equals true if not delete self. But why? Finalize ran, period. Delete self or not, it ran.
Right. I guess the only thing is inside the delete. Does it use the finalize ran at all?
Yes, yes, it does. Inside delete, finalize ran is one of 3 conditions for actually deleting the reference.
Right.
So the other one is that it's a strong reference, which is what was causing the problem here. Mm-hmm. The second one is finalize ran, and the third one is delete self.
Right, but basically, if you move the finalize ran to before it, then it's going to.
Then it will do nothing if delete self is false. It will still return without calling delete if delete self is false.
Right, but it won't do the deferral the first time.
Well, let me think.
Right, like basically,
yeah.
If it's using finalize ran, you're changing whether or not it's actually going to see that, because basically now it's always going to say that the finalize is run, and so when you hit that delete, you'll be deleting when you wouldn't have otherwise.
Yeah, let me think about that. That's a good point.
That's kind of why I'm like, you know, it's sort of like
no, you wouldn't, because although finalize ran is true, if delete self is false, meaning that the finalizer did not call an API delete reference in its code.
No, but delete self is different. Delete self is not who called it. It's basically a setting when it's created that kind of says, does this object delete itself or not?
Yes,
like if delete self is false, it will never delete itself.
Right, in which case, that kind of doesn't make sense, because if the finalizer runs, Well, okay, yeah. So if the finalizer runs and delete self is false, that basically says that the user wishes to hang on to the reference even though it's completely useless now.
Right. So that's a different, but I think the main concern here is that we're actually going to end up deleting things that we wouldn't have deleted before by moving that line.
That's true. Yeah.
Okay. So that's where it's back to, like, I think this is there's some it's very subtle in that, like, actually, yeah, the reason it's where it is because we don't want it to be set before that delete, and so moving it actually could.
Yeah. Okay.
So adding a check of it somewhere else is much safer than trying to tinker with the order.
Okay. Yeah. Okay. No worries. Okay. So then I'll change this. I'll change this to keep the finalize ran where it is, and then I'll add the additional check before we actually call the finalizer, because that also makes sense, right? To check there, like if the finalizer has already run, then don't run it again. It's as simple as that. And then that should be equally correct.
I think it's more like in delete. So let's see here. Because we actually, even though it has run, we will run through this again, and like we may actually do the delete. So where were you going to add the check?
To just before you're there already.
Okay, I just want to
see line. Oh, okay. So 278 or thereabouts.
Oh, I just think I just got into it. Which line did you say it was?
278 or thereabouts.
Okay. So there we go.
Yeah. So here, so 277 through 79, right? Right now it says finalize callback not equal null pointer, then call it. I would add finalize callback not equal null pointer and not finalize ran.
Right. Okay, so that's basically
that would be the sort of the
right. Okay, because normally finalize is only called once.
It should, yeah. It should never be called twice. Yeah, that's a recipe for a copious amounts of double freeze.
Well, except does like calling delete also run the finalizer as opposed to
no. The only way to so finalize is being called from the actual static V8 provided finalizer. That's there. So it's called from two places. From the V8 provided finalizer, yeah. Finalize callback is a very simple function that just calls the instance method. That's all. So yes, if you go down, that's all it does. Yes, finalize callback. Well, okay, it does the second pass thing, right? Because you can't call it directly. But see, the second pass callback, that's all it does is just call arrow finalize. So that's it. So finalize is being called from here, and you can see since it has no parameters, that means isenv teardown is false. And the other place it's called from is tilde nappy env, which calls finalize all, which runs over the linked list and just finalizes everything, right? So finalize is called from two places. So if it's called with what is that? Is env teardown false? That means it's being called from the garbage collector, right?
Right.
And so this is the first and last time that it's ever going to get called, right? And so I don't know that we want to defer there, because if we defer there, then we're never going to delete. I think that the deferring refers to when the user explicitly deletes in the finalizer. Then you want to keep going so where you say this is safe because, right? See, it says here this is you skip past
278.
Yeah. It says oh boy, this is safe because if a request to delete a reference is made in the finalize callback, it will defer deletion, right? So it's the delete function above this function that does the deferring, not this function. This function is supposed to actually delete, right?
Right.
And so by the time the finalizer runs, things should be set to delete, so it should actually delete, right? And I think you're using delete self here to mark that the deferring, because if you go up, you can actually expand, or no, this is the file, so you can just go up into delete. See here it says, if it's a strong reference, if delete self is true, or reference finalize ran, then delete yourself, right? So otherwise you set delete self to true, right? So meaning that the user has requested it, but you can't quite delete it yet because the finalizer may or may not have run, right?
Right.
So if delete self is already set to true because that's the nature of the reference, then this code will delete it, right?
Right.
Either way, whether it was called explicitly or whether it was called from the finalizer, it will delete it, right? So this code is the one that does the deferring. So if we're in the finalizer, we want the opposite of deferring because we know the finalizer has run. And so if we defer there, it's never going to delete ever again. On the other hand, wait a minute. No.
Yeah.
Yeah, because if we do delete, then we're pulling out the weak reference from the weak and useless reference from under the user's feet, right? And so when they do
if the
call
finalizers run once, like it should come through here. So this delete in the finalizer will be like the finalizer hasn't run the first, exactly, like it's the right. Okay, so this deletes self maybe end up, yeah, okay, so I guess I wonder, yeah, like is so is the problem that it's getting deleted twice, or is it
Wait
that
a
the
second.
finalizer getting called twice?
The finalizer is getting called twice. That's the problem. So I added a test case where you have a strong reference and you wait until environment teardown, right? And then at environment teardown, the finalizer must get called. Whether the reference is strong or not, it must get called. There's no question about it because the environment's going down, right? So then the problem was because it's a strong reference, you run the finalizer and it deletes itself because it's a strong reference, right? And so delete gets called because it's env teardown, and then it's a strong reference, so it deletes it, and then the rest of the code, even though you said it was safe, it was not safe, right? And so that's why I added the condition at line 275, right? If is env teardown, then you have to pretend it's a weak reference because it has to, because when you do call delete, it has to defer, right? But then if it defers, then it ends up back in the destructor, and it calls delete again, in which case the finalizer runs again, because the only condition preventing the finalizer from running is if there is no finalizer, if the function pointer is null, right? And so that's why it was running twice. And I verified that it does run twice during environment teardown. So
right. So okay. So basically, we're right. If we're in env teardown and ref count is greater than 0, then we say, okay, let's set the ref count to 0 because we want to
pretend it's a weak reference so that it does that whole deferring thing. Yeah.
But how does this? Okay, because we're calling finalize even though it's not. Right, the reference count is not 0.
I have an idea how to limit the scope of the impact. So what we could do is if finalize callback not equal null pointer, right, or bracket is env teardown amper finalize ran equals false. That would be the other way, because before I said if finalize callback not equal null pointer or finalize ran equals false, right? Or no, sorry, and finalize ran equals false. Then you enter here, right? But we could add to that finalize ran equals false and is env teardown.
Right.
You know what I mean?
And the reason you need to set the reference count to 0 is that because that's used somewhere? If
you don't set the reference count to 0 here, then and if the finalizer deletes the reference, then the subsequent lines will not be safe because finalize ran is an instance variable which will have been deleted by the user's call to an API delete reference. So that's why you have to, if in a garbage collection scenario, finalize will only be called. Finalize will be called by the garbage collector, right? And then it will delete because, let's see why. That's a good question. So finalize.
I just wonder, like that first line 275. I'm wondering, like, we're just ignoring the ref count, right?
I know why. I'm sorry. Let me just continue my thought. Okay. So the finalizer, under normal circumstances, only runs if it's a weak reference. If it's a strong reference, the finalizer will never run, right?
Oh,
So the
yeah.
fact that the finalizer is running means that it's a weak reference. And so, and so what? And yeah, okay, yes, that's right. Yeah, it's a weak reference. And so if delete self is set to true, it will actually physically delete the reference. If delete self is set to false, then that means the user for some strange reason wants to hang on to the reference even though it's already finalized. Okay, more power to them, right? So
Yep.
in that case, the delete self marks the fact that the reference, it marks the user's choice. However, if the user does delete the reference inside an actual finalizer call, then delete will have executed, which will have deferred, right? And
Yeah.
delete self will be true here, in which case it will actually delete the reference. So that's how we handle the regular finalization case, right?
Right.
Now, in the case of environment teardown, if the reference is strong, we have to pretend the reference is weak. We have to make it so, because we have to do this cycle, right? But so far in isenv teardown, we had this condition here that it will actually delete, right? And so if we don't actually delete here, then it's going to end up calling finalize again, because it goes back to the environment teardown. It goes back to the destructor. So that's the problem.
But how does ref, like, so I can understand it, like if line 277, if we basically add in there that says and
Whoa,
and
whoa, wait a minute.
right.
What an idiot. Wait, what have I done? Why did I move that finalize ran out? I said it would execute the thing twice, but why does it execute the thing twice? Because isenv teardown is true. It should go into delete. Oh, I know why. Okay, yes. Okay, so delete, the delete function doesn't actually delete a weak reference. It refuses to delete a weak reference, right? But
Okay.
we just marked the reference as weak, and so that's why it's not deleting, and that's why it's returning to the destructor. Holy cow, this is quite a bit of spaghetti here. Yeah,
Right.
so that's why I moved the finalize ran out to true, so it doesn't return to the environment teardown. Like, you don't want it to return to the destructor, because if it does, then it'll call finalize again, and so you need a tighter condition to not execute the finalizer. Yes. So that's.
You're saying in delete it checks the ref count and actually doesn't delete a ref.
That's right, because it knows that
it
if
may
it's
have already run.
Exactly. Yes. So
Okay.
So a ref count of 0 is like a disqualifying condition for immediately deleting in delete.
Okay. So that's why that part is necessary.
Yes.
And then I would like, yeah. So I think if we don't move the finalizer ran, but add into this line something that says only run the
Avoid running it
finalizer.
twice.
Yeah.
Yeah, once. Yeah. So then conceptually, I'm fine with that. Okay. So just we're over time. Let's not explore it unless you have some time, like a few more minutes.
Yeah, I'm just looking at my calendar. Yeah, I'm good for a few more minutes.
Okay, good. So then the other conceptual issue is, right, if you run the finalizer, whether it's null or not, conceptually you run the finalizer, then you want to unconditionally mark that it ran, because it's simply true, right? Like, you know what I mean? Like, you want idempotency, right? So you run the finalizer, you mark it as true, right? And normally idempotency means if finalizer didn't run, then run finalizer and mark finalizer ran, right? That's how you would do idempotency for the finalizer, no matter what the circumstances, right?
Yeah, I'm not quite sure why it's in an. You're saying basically like, yes, leave it where it is, but don't have it in an else.
Yeah, exactly. Like the finalizer didn't run because delete self was true. It ran, period, irrespective of what delete self was.
Yeah.
You know what I mean?
So I get that.
So if we leave, I understand the concern about code churn, and I share it, right?
Yeah.
But on the other hand, if we use finalize ran as a condition for checking whether it ran or not, then it would make sense to set it to true when it actually ran. Because then we're saying, like, don't run the finalizer twice. Use finalize ran to see whether it already ran, but then you're not setting it when it ran every single time. There may be a condition where it ran and you're not setting it.
Right.
You know,
I mean, I
pretending
guess,
it didn't
and I guess, you know, if delete self is true and we actually call delete, can the finalizer ever be called again?
No, because we're running this from the finalizer, which was run from the garbage collector. So the garbage collector is certainly never going to call finalize again.
Right. So in theory, removing that else should be safe.
That's what the tests are indicating.
Right. Okay. So I think I'm okay with that, like taking off that else.
Yeah, and we can keep
Either
this
you've
change in
deleted
mind.
it or the finalize is run.
Yeah.
So, but
Yeah,
I like.
because
Yeah. Sorry. Go ahead.
oh yes. If we move that out and delete self is false, right? Then we will retain the scenario where the user wants to keep around a useless reference, because finalize ran may be true, but delete self is false, and so it's never going to call delete, right? Until the user explicitly calls delete, in which case finalize ran is true, the reference is weak, doesn't matter, because finalize ran being true is one of the conditions for actually deleting it. So when the user subsequently deletes the reference, it will work.
Right. Okay. So I think
Actually, I can run a test. I can create a test for this.
Yeah.
Because
I think that would be
you know,
good.
okay, the finalizer can call back into JavaScript and say, okay, the finalizer has run, and then JavaScript will call like a native binding which explicitly deletes the reference. So I will add a test here that will address that scenario. I will intentionally keep a useless reference hanging around.
Yeah. So I think what would be good would be like if we take that else, like put a comment in that says this needs to happen after, like don't move this higher up or anything like that.
Don't move what higher up?
The finalizer ran.
Okay, wait a minute. I was of the impression that you were okay with keeping it where it is in this PR, i.e. unconditional.
No, because I think it affects delete.
It only affects delete if delete self is true, meaning either the user called delete from the finalizer, or it's such a reference, in which case it should be deleted here because the finalizer has already run. If you don't delete it here, you'll never delete it.
But I think we overloaded, like we sort of borrowed delete self to defer things. Like
Yes.
even if we were gonna defer it, like we basically said, okay, in the delete, we're gonna say, oh, the finalizer hasn't, you know, doesn't tag as having run yet, so we're gonna defer deleting it. But if we actually change, if we actually, like I think if we actually move that underscore finalize ran, it's gonna break what we do in delete.
But only if delete self is true, right? In which case you want.
But we change that. Like I think what happens is it comes through and says, okay, delete self is not true, or
Yeah.
and
then skip.
And then so we defer it. But I think that means that the user
wants to hang on to the reference.
Yeah, right. So, but for normal cases, it starts out being true.
Yeah, which is good, because then it'll go in there and delete, which is what you want.
Well, no, but I think it's the opposite. If delete self, we go into delete, and if the finalizer hasn't run, we don't delete it.
No, we do delete it. It also delete self being true is another one of the three conditions under which it will immediately delete, which is exactly what you want.
No, but the finalizer hasn't run yet.
Check delete. That's fine. Check delete.
Delete. Which line numbers was that?
Oh, I don't know off the top of my head, but if you search for capital delete, yeah. Right. So see, so delete self is also a condition for immediately deleting. Whether the finalizer has run or not doesn't matter. If it's a delete self reference and you end up inside delete, you delete the reference, which makes perfect sense because you do this at the end of the finalizer. This is your last chance to delete the reference before it leaks, right? Because the GC will never call the finalizer again. So if the reference itself is set to self-delete, then it doesn't matter whether the finalizer ran or not. You will immediately delete the reference. The only time you will defer is if delete self is false and the reference is weak and the finalizer hasn't run yet, right? Meaning that I don't even know what that means, honestly. Like, Why would that ever happen? Why would you call delete? I guess weak reference, delete self is false. Yeah, okay, yes. Okay, I know the circumstances that this covers. Is you have you have created a weak reference and you call nappy delete reference before the finalizer runs, right? In that case, it doesn't actually delete the reference until the GCS has had some time to call the finalizer. That's what happens.
Right.
So that's what this case covers, and that's fine. That works too.
Right. So because we changed this delete self.
Yeah. So conceptually, what this says is the user called an API delete reference, right? But we know that there's a finalizer attached to it, and so we don't immediately want to delete it. That's what we're saying there.
So delete self is false.
Yep. It'll never get here until the user explicitly deletes the reference.
Yeah, I'm still uncertain. I still have a feeling like the ordering was really
Important.
tricky
Yeah.
to get right. I mean,
Okay.
I could be wrong. Like, I guess where I thought you were going is like that else shouldn't matter.
Yeah, basically. Yeah, I guess so. Yeah, because delete self takes care of that, right? So if delete
Kind of
self
like
is
if you like if you've deleted, then you are never going to get like, well, actually you've deleted this, so maybe you have to avoid setting finalize anything in, like, should you not be setting something there because you've just deleted yourself?
Oh, no, because it's not. No, it doesn't. It doesn't. The way the code currently is on the main branch, it's an else, right? So either you delete yourself, or
Right.
you safely set that to true, right? But right now you're setting it safely to true before you delete yourself. So it's also guaranteed to be safe. So there's no chance that you're going to access an instance member of an instance that was already destroyed, because you're accessing it before you even have a chance to call destroy, and you may not call destroy if it's not set to delete itself. So do anything you do before delete is safe, right? So that should not cause like an invalid access.
Yeah, no, I meant like, I thought you were talking about getting rid of the else, but the else maybe like where it currently is, the else is kind of probably needed. I'd have to
Okay.
spend a bunch more time thinking about it to really convince myself, because I know it took me a long time to figure out why that sequence was good.
Okay. Oh, I see.
I
Okay.
think like I'm happy if you like, maybe we can do that, but it'd be easier if we just change that if finalized callback line.
Okay. Okay. Fine. Okay.
That I
will
could
add
easily
additional.
review and say, yeah, it doesn't affect anything else. Let's do it, right?
Okay. All right. Okay. No
Okay.
problem. I'll change it. I'll because finalized ran will be marked as true in this case, and it'll just get back to the destructor, and then it'll come back in here because the destructor of an API environment destructor will call this function twice, but
Right.
it will only call the user's function once, because the second time around finalized ran will be marked as true.
Right.
So then
We could even, like, in that, I just wonder, I don't know if this makes sense, but like in that 275,
yeah.
we could set the finalized callback to null after it's like in that is
Oh, I
turned
see what
down
you
and
mean.
reference, like then a bracket that says set the ref count to 0, set the finalized callback to null pointer.
Oh, you know what? That's even better, because that's idempotent right there. It's like, if finalized callback not equal null pointer, call the finalizer, set finalized callback to null pointer, because then no matter what, it's impossible to call it twice unless we're intentionally dereferencing a null pointer, which is absurd.
Right. Yeah. Because I
Yes,
mean,
you're right.
because that one would be like, okay, we've called it. Yeah, now you can't call it anymore.
Yeah, exactly. Yeah. Okay, that's great. Okay,
and maybe that's just a useful, like that there's no way that should be able to affect anything else.
No, I mean it makes sense, right?
Yeah.
If there was no finalizer callback, then there will be 0 calls to a finalizer callback. If there was a finalizer callback, there will be exactly 1 call to the finalizer callback. It's impossible for there to be 2.
Yeah.
All right, great.
And then
yeah,
the first one is force. I think a little bit better comment on 273. That's kind of like that explains how that's basically setting it to a weak reference would be good.
Yeah. Okay. Yeah. Okay. I'll improve the comment and I'll add the finalized callback equals null afterwards, and I'll leave everything the same.
Yeah. Okay. That sounds good.
Okay. Great. All right. Sorry to keep everybody.
Yeah. Okay. Okay. So that is it for next week, unless anybody else has something they want to bring up. Okay. We will talk to everybody later. Bye.
Bye, everybody.
Thanks.